Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's intensive math class. Today we're going to continue with percents, but we're going to talk about percents in a different form. We're going to talk about proportions and similar figures. Now, some of you may say, wait a second, how do percents relate to proportions and similar figures? Well, guys, if you remember, okay, a fraction, for example, 1/2, can be turned into a decimal, which is 0.5, which can be turned into a percent, which is 50%. Fractions, percent, and decimals, they can have the same value just in different form, okay? So when we're talking about proportions today, before we could really describe what proportions are, we really have to talk about a ratio. And a ratio, my brothers, is simply a fraction. A ratio is a comparison of two numbers that can be written in three distinct ways. A ratio can be written in fraction form, A over B. You would read that as A to B, though. A ratio can be written in the form where you have A colon B, also read as A to B. And a fraction, a ratio can also be written as literally A, the word to, and a B. So those are the three ways to write a ratio. It's very important. You're going to see this on a lot of standardized tests. A lot of times when you're reading word problems, a lot of different scenarios you will see ratios. If you've ever purchased a model plane or a model car, you're going to have what's called scale, which we will talk about later. And they're going to have a scale written in one of these forms. Usually scale will be written in this form right here, A colon B. All of those, though, are ratios. They're A to B. The cool thing about ratios and the important thing about ratios is that not only do they compare two numbers, but they compare two numbers with the same unit. Okay? Let me explain what that means. For example, the ratio of boys to girls in the classroom is 5 to 7. Although we're talking about boys and girls, which are two different genders, they are still the same unit of a human being, correct? So that's why we can write a ratio of that. So the ratio of boys to girls is 5 to 7. Since I had mentioned boys first and 5 first, 5 relates to boys. Since I had mentioned girls second and I have the number 7 second, 7 relates to girls. So the ratio of boys to girls, if it's 5 to 7, would be 5 to 7. Excuse me for 1 second, I'm so sorry. Okay, sorry about that, thank you. Now, let's look at another example. The ratio of A's to B's in the class is 9 to 14. So since I'm looking at the ratio of A's, the first unit, to B's, again, those are two different letter grades, but they are still the unit of grades. So I can write a ratio here. And A's to B's is 9 to 14. 19 A's to 14 B's. That is how we work with and write ratios. Now, I could have written this as 9 to 14 as well. And you already have 9 to 14 in words. Just like the example above, I could have written it in as 5 colon 7. But usually, fractions are the best way to express ratios because then you can reduce them, you could add them, you can multiply them, you can divide them, etc. So now that we understand what ratios are, we got to talk about proportions. And proportions, my brothers, are two equal ratios. And in order to check for what's called proportionality, in other words, in order to check to see if two ratios are proportional, you're going to go ahead and cross multiply and compare the cross products. So for example, if I were to tell you, are the ratios 3 to 5 and 6 to 10 proportional? Are they equal to each other? Well, let's see. Let's cross multiply. 3 times 10 is 30. 5 times 6 is 30. You now check the cross products. 30 does equal 30, so yes, 3 to 5 is proportional to 6 to 10. That's how you check for proportionality. And by the way, that's how you're going to solve proportions later on. If I tell you something is proportional and I need you to find a missing value, you're going to cross multiply and solve for that missing value. In fact, we've already done that. Remember when we were finding percents, parts, and wholes, guys? And we used x, which is the percent over 100, equals is over of. Guess what? We were already working with proportions. Okay? So now we're just defining it a little bit more clearly. So, how do we use proportions to solve problems? Well, number one, very important, guys, find the fact ratio. That's a made-up word for me, okay? I just made that up. But it's very, very useful. Whenever they give you a proportion word problem, they're going to give you a fact. They're going to give you a set ratio already. A fact. That's etched in stone. You're going to use that as your fact ratio. And then you're going to set up a proportion with another value that they give you and an unknown that you're looking for. And when you set that proportion up, you better make sure that you go from the same unit to the same unit. Okay? I'm going to explain what that means in more detail, but keep that in mind. When you're setting up proportions, go unit to unit, unit to unit. Okay? What is this man talking about? Let me explain. Example. Mr. Morrow can grade 3 tests in 15 minutes. How many tests can Mr. Morrow or can he grade in 2 hours? What is the fact ratio here? What is the fact? Sir. Very good, my brother. The fact here, guys, is that Mr. Morrow can grade 3 tests, we'll call T, in 15 minutes. Okay? That is a fact. Why? Because the problem told you that that is the fact. You with me so far? All right. Now, I want to set up a proportion. I want to find the number of tests he can grade in 2 hours. Remember, unit to unit. So if I have 3 tests up here at the top, what do you think goes over on the top of the other ratio? X tests. So XT. Because remember, I want to go unit to unit, test to test. Now, on the denominator of my fact ratio, I have time in minutes. How much time do they give us here? 2 hours. But what is 2 hours in minutes, guys? That's exactly right. 2 hours would equal 2 times 60 minutes in every hour equals 120 minutes. So down here would be 120 minutes, unit to unit. Does that make sense, gentlemen? You promise? All right, now it's easy. Once you set up the proportion, guys, cross multiply. So I got 120 times 3, which is 360, equals 15 times x, which is 15x. The relationship between 15 and x is multiplication. You cancel multiplication with division. So you divide 15 to both sides. And x will equal 24. How did I get that number? You just divide, guys. 15 on the outside, 360 on the inside, just in case you need to see it. That goes 2, that's 30. That's 6, drop the 0, and that goes in 4 times. So 24, but actually 24 would have been a wrong answer. He can grade 24 tests. Why, Mr. Morrow? Because that's what he was looking for. When you have proportion problems like this, you have to label the answer. Did we solve for tests? Did we solve for minutes? Did we solve for cookies? Did we solve for apples? Did we solve for orange juice? What did we solve for? In this case, we solved for tests. Mr. Morrow can grade 24 tests in 2 hours using that fact ratio. Does that make sense, boys? All right, let's do another example now. Mary can sew 3 buttons on a shirt in 4 minutes. This time we're changing it. How much time will it take Mary to sew 15 buttons on a shirt? What is my fact ratio here, guys? What is the fact that they gave you? Not just 3 over 4, 3 buttons for every 4 minutes. You feel me? Okay, now, how can I set up the next ratio to complete this proportion? Yes, sir. No, read. 15 buttons over X minutes. Yes. Mr. Morrow, how did you know to put it that way? Unit to unit. Unit to unit. Buttons to buttons. And minutes to minutes. That is very, very important that you remember that, guys. Go unit to unit. Now, let's cross multiply these bad boys. Very good, my brother. Very good. See how knowing multiplication helps? Excellent. I'm very proud of you. 3x equals 60. Divide by 3. So x equals 20. 20 what? No. Guys, 20 minutes. That's why you label. Does that make sense, boys? On the tests and on the quizzes, guys, I promise you, if you don't put the labels, I have to mark it wrong. Because then I don't know what you're solving for. You feel me? All right. May I continue? No? Okay. No worries. I'll pause it real quick. Thank you. Okay, boys. Thank you for your honesty. Let's move on. Scale. Scale is a way to represent objects and figures in smaller or larger dimensions. Okay? The best way I can explain scale is with an example. Right here, what you have here is a scale model of a cruise ship. A cruise ship is enormous, right? It's very, very large. I wouldn't be able to fit a real cruise ship inside of this room, let alone a little picture frame like this. So this is a scale model. A scale model is a way to represent something really, really, really large in a smaller format, or something really, really, really small in a larger format. For example, the Earth. There's a scale model of the Earth called a globe. And you can spin a globe and look at all the continents and all the countries and, you know, all the states in the United States of America, all the countries in Europe, all the provinces in Asia. It's a scale model. If we didn't have a scale model of Earth, we wouldn't know geography. We wouldn't know where anything is. Because in order to really study the Earth, you either have to go around the globe on a boat and circumnavigate the globe, or go on a spaceship, literally, and circumnavigate the globe in space. Now, since we can't usually do that very easily, okay, it takes a lot of time and money and supplies and effort and knowledge, they've created scale models. If you've ever owned a Hot Wheel, a little, you know, toy car or toy truck, that's a scale model of a real car or truck or fire engine. Okay? Toys. When you guys buy toys, an action figure, okay, from like, let's say a movie. The action figure is a lot smaller than the actual human being. That's a scale model of the actual size. So think of that in scale. Okay? Now, another way that scale is used very, 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 very often is with maps. Okay? This is a map, as you can see. of the United States of America. And I have a ruler on top of this map. And this map, I've given you a scale. Okay? And actually, I messed up. That should be 350 miles. I apologize. No excuses. That's my bad. So the scale reads 1 centimeter on the ruler really represents 350 miles in real life. This, by the way, guys, is how your GPS works. Your GPS has a scale within it. And when you put in distances, it calculates using the scale. That's why the GPS tells you how far away it is, how long it's going to take you to get there, etc., etc. Okay, it's pretty cool. But we're going to use the old school method today. On this ruler, you can see the red highlighted part of the ruler here. This measurement of the ruler is 8.5 centimeters. That's going from California here to about Tallahassee, Florida over here. Okay? Roughly from California to Tallahassee on this particular metric ruler, it reads 8.75. Oh, and actually, you know what? That's wrong. Hold on. It changed from imperial. There we go. Hold on. I want metric. There it is. Sorry, guys. Okay, now it's metric. It went to imperial there for a second. And this should be about here. Okay, sorry about that, boys. My bad. So this is an imperial, just so you know, means standard, like inches. Metric is meters, centimeters, kilometers. So on this metric ruler, I have 8.5 centimeters from California to Tallahassee. I want to know, what is the actual distance? Well, guys, same procedure. What is the fact that we know? There it is, my brother. We know for sure a fact. The fact ratio here is that 1 centimeter equals 350 miles. Now, how do we set up the next ratio to set up a proportion to find the actual distance from California to Tallahassee? Yes, sir. No. 8.5 centimeters to X miles. Now, again, you had said it incorrectly at first because you didn't go unit to unit. They gave me 8.5 centimeters. Unit to unit. I'm looking for the actual miles. Unit to unit. That makes sense? Does that make sense? Okay. So now let's cross multiply, boys. So X will equal 350 times 8.5. That's 0. That's 25. Carry the 2. 17. Skip a space. 0. That's 4. That's 28. So it's about 4,550 miles. It's a little bit inaccurate, but you get the point. That's how you find distances using proportion. Another example of how proportion is so important. You got to be able to go unit to unit, though, guys. If not, you will get all of these wrong. You have to read, and you have to go unit to unit. Let's take another example. If the scale model of a car, okay, is 1 inch to 6 feet, find the actual length of a model car that is 3 inches long. What is my fact here? What is the fact? The fact is that this model has a scale of 1 inches to 6 feet. How can I set up my next ratio? Very good, sir. Very good, my brother. Very good. Inches to inches, feet to feet. They gave me 3 inches. I'm looking for the actual feet. Very proud of you. Cross multiply. X equals 18 feet. Why feet? Because that's what we're looking for, X feet. So X equals 18 feet long. That is the actual size of the car that was modeled by this toy. Does that make sense, gentlemen? Promise? All right. Now, last but not least, similar figures. Before we talk about similar figures, guys, I got to show you. This is a similar representation. That little symbol means similar. And later we're going to see something that's called congruent. Congruent is this symbol. That's called congruent. And congruent means equal. Similar is not equal. Congruent is equal. So what is similar? What does this mean, Mr. Moore? Well, similar figures, first of all, must have the same shape. They have to have the same shape, period. Number 2, they have a different size. They're different sizes. If they're the same sizes, they'd be congruent, not similar. Number 3, corresponding angles are congruent or equal. And corresponding angles are congruent, sorry about that, and corresponding sides are proportional. Now, before I can explain to you how that works, we got to talk about what corresponding means. Whenever you're trying to find corresponding angles or corresponding sides, you never look at the figure. You always look at the letters that they give you. Let me explain what I mean. Here I tell you very clearly, triangle ABC is similar to triangle DEF. So let's first go over the corresponding angles. The first letter is my first angle of the first triangle. That corresponds to my first letter of the second triangle. So angle A and angle D are corresponding. My second letter of the first triangle and my second letter of the second triangle are the next corresponding angles. So angle B and angle E are corresponding. Okay? And my third letter of my first triangle and my third letter of my second triangle are corresponding. So that means that angle C and angle F are corresponding. So now that we know that they're corresponding, yes, sir. If you guys have any questions, ask me, please. Thank you. So now that we know how to distinguish the corresponding angles, we go by order. Now we know that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F, because that's part of being similar. Now, corresponding sides. Corresponding sides, a little bit different, but just as easy. Okay? Corresponding sides works like this. See this side AB? Okay? AB corresponds to DE. Why? We go by the order of the letters. So side AB and DE correspond. Next, BC, the next 2 letters, corresponds with side EF, which are the next 2 letters. So BC and EF also correspond. And then last but not least, the first and the last letter correspond with the first and the last letter of the other triangle. So that means that AC corresponds to DF. Okay? You have to understand this, guys. In fact, on the quiz, I'm going to have one question on the test. I'm just going to say, name the corresponding angles and name the corresponding sides. So if you don't see this, now is the time to ask me, my brothers. Okay? This is your time, guys. If you don't ask, it's because you're telling me that you understand it. Yes, sir. What don't you get? You go in an order. What do you mean, how do I put it in order? Thank you for asking. Look, the first two letters and the first two letters, A, B to D, E. Then B, C to E, F. Then A, C to D, F. Thank you very much for your honesty, kid. Come again? Yes, because there are three sides, aren't there? So there's three corresponding sides. Now, how does this apply to actual math and solving things? Very simple. Find the value of x. Okay, very simple. In my first triangle here, ABC, I have side AB is 8, BC is 6, and AC is 10. I have a second triangle, DEF. DE is 4, EF we don't know, and DF is x. I want to find the value of x. So we're going to write a fact ratio of the first triangle, and then we're going to use corresponding sides of the second triangle to solve it. So 8 to 10 will equal. Who corresponds to 8 here, guys? The 4. Who corresponds to 10 here, guys? The x. See what I'm saying? This guy, AB, corresponds to this guy, DE. And then this guy, AC, corresponds to this guy, DF. Does that make sense, my brothers? Now, simple. Thank you. It is simple, my brother. Thank you. God bless you. 8x equals 40. Fantastic. That's it, brother. So x equals 5. That's it, baby. Done. Does that make sense? Promise. Promise? Okay. So you just got to set up the right proportion using corresponding sides. Yes, sir, my brother. Okay, the 6 in this case didn't have to be used because I was just solving for x. Now, how about this? Now that you asked that, thank you, I'm proud of you. What if I tell you now, how would we solve for y? What proportion will we use? 8? No. No. 8 to 6 would be set equal to 4 to y. Very good, boys. Cross multiply, gentlemen. 8y equals 6. Not 6, sorry. 8y equals 24 divided by 8. Y equals 3. Does that make sense, boys? Okay. Any other questions on this so far? Okay. Now, how about this bad boy? Okay. Example 2. A man that is 6 feet tall casts a 4-foot shadow. At the same time of day, a tree casts a 30-foot shadow. Find the height of the tree. Very simple here, guys. Very simple. You're gonna have to first of all create a little triangle. Here's the man, and the shadow that he casts is 4 feet, and we know that he is 6 feet tall. Go ahead and make a triangle there. Now the tree casts a 30-foot shadow. But do we know the height of the tree? So that's X. Very good, gentlemen. Create a triangle. You have now created two similar triangles. So what proportion will we use to solve for X here? Yes, sir, my brother. Okay, 6 to 4 will equal height to height, shadow to shadow. X over 30. Very good. Very good, guys. Height to height, shadow to shadow. Cross multiply. And I've got 4x equals 180 divided by 4. And x is going to equal 45. 45, guys. 4 goes into 180. That's 4 times. That's 16. And then that's 5. So the tree is 45 feet tall. Does that make sense, guys? Does that make sense, guys? Yes, sir. Does that make sense, guys? Any questions, gentlemen? Okay, thank you very much. I hope you learned a lot and have a wonderful day.